This lesson will show us how to graph piecewise functions. A piecewise function is defined by different functions on different parts of its domain. Okay, so as we take a look at this piecewise function here, we notice that there are three components to it. We have x squared if x is less than 0, 2 if x is equal to 0, and x plus 2 if x is greater than 0. If we wanted to find a particular value, let's say f of negative 2, then f of negative 2, we know that negative 2 on our number line is less than 0. So we're looking at this particular function here, which means we plug in f of negative 2 into the x squared component. Negative 2 goes into the x squared component. So negative 2 squared will give us positive 4. So f of negative 2 is 4. Okay. If we plug in the value of 0, f of 0, then as we look on the number line, 0 is at 0, and on our piecewise function, when x is 0, that's going to be the middle component there, right? So we say that f of 0 will give us a value of 2. And then if we do f of 3, then 3 is to the right of 0, it's greater than 0. So 3 is going to be in this part of the piecewise function when x is greater than 0. So then we plug it into x plus 2. So we say 3 plus 2, or that gives us 5. So f of 3 will give us 5. Okay, so from here, let's go ahead and graph what we have. If the graph is less than 0, so anything to the left of 0, you have a parabola, x squared. So I'm just going to go ahead and graph that. Okay, something like that. Okay, and also be aware that because x is less than 0, it actually cannot be at 0. So that means I need to have an open interval, an open circle, saying I don't want to include the value at x equals 0. Oh, where's my coordinate plane? There it is. Okay, for the next one, f of x equals 2 if x is 0. So when x is at 0, the y value is only going to be 2. So I just put a dot right there saying I can have that point. Okay, and then lastly, f of x equals x plus 2 if x is greater than 0. So anything where x is greater than 0, all of this territory over here, then we want that x plus 2 equation, that line. So x plus 2 would have a y-intercept at 2, and from there we can draw a linear equation with a slope of 1 up, right, like that. So it looks like that. Okay, now technically this particular function says when x is greater than 0, so you have an open circle at that location. However, the open circle with the closed circle that was from the previous part of the piecewise function kind of closes it all up, and it becomes a closed circle again. So this is still going to be a closed circle right there. So your graph, basically your final graph will look like this. Okay, so determine the domain of f. Well, what we can see here is that what are all the possible x values? Your x values start way over on the left side, negative infinity, and your x values always exist, even at this break. Even though your x value doesn't exist here at 0, your x value of 0 still exists here. So x value still exists there. And x value exists everywhere else as well. So for that reason, our domain is negative infinity to infinity. Our graph F. We did that already. There's part C. Okay, part D. Use the graph to find the range of F. So now we're going to find the range. So you notice that there's no y values here, right? So we can't have any y values here, but the y value does start at this location and work its way up on both sides. So where does the y value start? Well, notice here, again, you have an open circle here. So you do start there, but at the same time, y cannot actually exist at this lowest point. So for that reason, we say that we start at 0, but don't include that 0, which means you need to unbound it. You do it with parentheses. And then from there, in interval notation, the y value's largest value is going to be all the way up there to infinity. So we're going from 0 to infinity. Okay. Is f continuous on its domain? Well, recall from our previous lesson that we said if you can draw along the graph without lifting up your pencil, it is continuous, right? So every single x value exist, but at the same time, you can't have any jumps. In this case, we do have a jump right here, this jump discontinuity. And so for that reason, this graph is not continuous. Okay? At x equals 0, there is a jump discontinuity. Okay? All right, that'll do it for piecewise. Do the other one on your own.